Hey everyone, I'm Gokul, again from Hotwired, and I'm going to be talking about PTC Creo. So how many of you use Creo Parametric right now? Okay, you guys, no one else? How many of you use CAD software in general? Okay, that's interesting. Okay, you can go to the next slide. So the main objective today is just going to be to kind of give you an overview of PTC and how to get started, basically, and also provide you some information you need to apply it to FTC. So so we're going to get started, show you where to download the software and some tutorials that you can use to learn it, and then also talk about modeling some basic parts, assemblies, and doing some analysis. And these are 3 things that are very helpful when it comes to FTC. And finally, how to make some animations to show off your model. So here's a website that you can go to download the software. It's free for FTC teams. So you just have to go to ptc.com/go/first. And in this website, there's also a training file, which is called How to Model Almost Anything. And this is really useful. It has a lot of tutorials and different exercises that'll get you really familiar with the software. And you can model several different parts. And it'll also show you some basic kinds of analysis you can do with the software. And these are all really helpful. And once you go through this tutorial, you'll be ready to model a robot. And you can also use How to Develop a Product, which is basically a tutorial that shows you how to go from concept design to a final product. So yeah, to get started, when you actually download Creo off of the website, there's several Creo softwares. There's Creo Direct, Creo Analysis, but the one you're going to be using is Creo Parametric. That's where you do all the 3D modeling. And you're also going to want a good 3-button mouse. And what this means is that you see that scroller in the middle. It also has to be able to act as a button. You have to be able to press it because you're going to need both of those functions to manipulate your models. So these are the applications that are downloaded with Creo, just an example. But the one that's circled is the one you'll be using, Creo Parametric. So there's 3 basic types of files in Creo Parametric. So there's parts, which is the most basic type of file. It's just a simple, let's say a channel or a wheel or something. And assemblies are when you put the parts together and have them interact in certain ways. So your whole robot, for example, would be an assembly with multiple sub-assemblies. And then there's drawings, which are really useful for kind of highlighting certain features of your robot and giving kind of a blueprint format of the part, as you can see over there. So this is an example of how you can manipulate a model. So as you can see here, this is basically a basic bike assembly. So you can play the video. And as you can see, you're just manipulating it using the middle mouse button. If you hold it down and move around the mouse, you can look around your assembly. And you can also change what you can see in the assembly. You can either see a plane view, where you could see all the planes, or you can just see the center of rotation. And as you can see, if you drag this pedal, it also moves the wheels. So this is an example of a relationship between 2 parts that are used in an assembly. And as I said, this assembly is made up of several parts. So you can actually open up these parts in real time. And when you make edits to them, it'll change the actual assembly in real time also. So as you can see, basically, this is the stem of the pedal. And this is the original pedal shape. So once you make the extrusion, you can shell it out and make those curves that you see on either side. So those are 2 basic functions that I'll talk about later. So yeah, but that's basically a part. And this is a more complex assembly. This is like Da Vinci's flying machine. So this is much more complex than the bike. There's a lot more components that interact in different ways. So as you can see, we're going to spin that lever, and it moves the entire system. So you can see the wings flapping, and there's also that gear turning. So they're all related. So moving on. So this is the kind of the basic functions that you're going to be using to actually, model your parts in PTC. So the most basic and most used function is extrusion, which is basically just making like a 2D sketch and then extruding it in one dimension perpendicular to the sketch axis. So it's like if you draw a circle and then make it into a cylinder. That's basically what extrusion is. And all of your parts, and most of your parts, like the basic Tetrix parts or custom parts that you use, you can probably make them using extrusions. But there's also a revolve. So as you can see, that same cross-section that's used for the extrude has been revolved around an axis to make kind of a wheel shape. And then there's also sweeping and blending, but those are two things you pretty much never use when it comes to FTC, but you might use them in other cases. So in terms of assemblies, when you set these assemblies up, you have to bring in different part files, and then you actually have to make them have a relationship to each other, and these relationships are called constraints. So there's two types of joints that you can use. In FTC, mainly you use static joints and kinematic joints. So static is basically, to put it into perspective, anything that's welded onto your robot or screwed. So anything that's stationary and doesn't move around at all. And then there's kinematic joints, which is when a part moves in relationship to another part. So there's two main types of kinematic joints that you're going to be using, which are pin joints, which is like when a part moves around another part, so like a wheel. And then there's slider joints, which is what you would use to make linear slides. So here's another demo. So if we open up the video, basically this is an example of the mechanisms I was talking about earlier. So not only can you set up assemblies, but you can actually have them interact in more unique and detailed ways. So as you can see, we have two wheels, which each have 80-tooth gears behind them, connected to one 120-tooth gear in the center. So right now they spin independently, which obviously isn't what you want, because that's not realistic. If they're interlocked, they would move in relationship to each other and at the same time. So as you can see, there's those two similar type of gears behind each wheel. And then you have the big gear in the middle. So now we're going to actually set up the mechanism. So if you go into applications and choose mechanism, and then you can set up gears. So basically you choose one gear and then another. So as you can see, you're choosing those two axes, and you set the ratio. So in this case, it's the gear behind the wheel, which has 80 teeth, to the gear in the middle, which has 120 teeth. So you just enter those values, and once you apply that mechanism, you can see that they actually move together. But you also need to set up the other set of gears. So you set up the middle wheel to the middle gear to the side wheel. So that's an 80 to 120 ratio instead of 120 to 80. So once you set both of those up, as you can see, we're going to drag one wheel, and it'll move all the rest of the gears in the way that it would move in real life, according to those ratios. So an example of some analysis that we did when it comes to last season. So Robin talked a lot about the sprocket-based wheel design that we used and that we had at the start of the season before switching to a 4-wheel drivetrain. So basically, we designed these wheels as if they were moving across the churros like a sprocket would move across the pins of a chain. So you can see we actually made that channel that they're all on a slider joint with the piece behind it, so it moves across that axis. And all of those have pin joints, and they're relative to each other, so they move at the same time. So as you can see, they kind of smoothly move across those pieces. So yeah, PTC is really helpful for just, it would take a lot of time to build all those parts out and set them at the exact offsets that we use in this model. So it's just a really quick way of testing out if they would actually work instead of investing all the time of building it. So this is an example of concept design. The specific picture is taken from the How to Develop a Product tutorial. But basically, we did this in our past couple of years. It just at the start of the season, when you don't really know exactly what your parts are going to look like or your components, you can kind of assign like blocks to estimate how much space they'll take up in the robot. You might have a block for like the drivetrain, and then for the bucket or scoring mechanism. And if you have a hanger, you might have a block for that. So once you set up all these blocks, you can actually set up their weights and then test the center of gravity if they're on a ramp to see if it'll tip over. So you can do a lot of things like that before having to model each specific part of the robot. So this is an example of just using sketches for concept design. You don't necessarily have to model everything in 3D. You can just create simple sketches and then see how mess around with the dimensions and see how they would interact. So as you can see here, this is an example of a robot with a bucket attached to it. And you can manipulate that, that dimension, and you can see the bucket moving. So just a nice way to kind of test out the dimensions before committing to a full 3D model. So the nice part about PTC is that since they sponsor FTC, they actually have a preset, they have all the files that you'll need for your basic Tetrix parts and all the field parts for the season. So you don't have to spend time modeling those. They're basically just provided to you, so you can just go to the website and download them. And you can pretty much quickly make your robot and test it on the field just with the files they provide you with. So yeah, this is an example of they provide you with the field model. So we've put our concept design for our robot onto that ramp model that they provide you with, just to test out if the bucket would reach the goal in the right way. So you can do a lot of things. As you can see, that's obviously not a fully developed model. It's just some simple channels and the linear slide with the bucket. But this is a great way to test out, the reach without building the piece. And here's an example of analysis that you can do. So as you can see, that's the center of gravity of that piece when it's of that block when it's on the 60-degree incline. And once you apply physics to it, you can see whether or not it'll tip over, basically. And as you can see, it did tip over. And the reason it went through that, that ramp is because we didn't set up object collision. But yeah, that's just an example of how you can see if objects will tip over. So basically what we did was we assigned the material and the weight to that block without actually having to model our entire robot, and saw if that kind of rectangular prism shape would work in terms of center of gravity and weight. So here's slow motion. Okay. So this is these are all the types of analysis that you can do with PTC. So there's, you can see how sub-assemblies fit together. For example, when we first set up our linear slides last season, they were interfering with parts inside of our chassis. So instead of, building all those parts out and taking the time to change them, you can just see how the parts would fit together. And this also goes back to that concept design I was talking about earlier. And then there's material selection, which is basically when you assign material to different parts like aluminum or plastic, and you can actually see how they affect things like the center of gravity. And in real time, you can see how different materials would affect, the properties of the robot that are important to you. And finally, there are animations, which are basically just, short videos of your model doing things that the robot would do in real life. So we have a quick video from 2014. So in our first year, we invested a lot of time into this animation, and we made it look really nice. So all of these effects are made with PTC. So I mean, of course, this isn't the base model. We added the reflection and everything and made it look shiny. But yeah, so this is an example of an animation. Basically just showcases the robot and some of the components and how they move around. So one thing to note about PTC is that it is a little difficult because there's a lot of features and it's kind of hard to learn at first. But in the end, it's pretty worth it because there's a lot of things you can do and a lot of freedom that you have when you're making your models. But in terms of animation, one thing that we've noticed is that, when we go to super regionals, the teams who tend to win the PTC award have really nice animations, and they're usually made with like AutoCAD. So this PTC isn't necessarily the best for animations if you don't have that full control over the software, but it's really great for concept design. And as I said earlier, they provide you with field parts and things like that. So it saves you a lot of time. So another great use of PTC is 3D printing. So we got a 3D printer before our last season off of a grant. So we started using this to full effect. Basically, as Justin talked about earlier, we made little USB relief parts. So basically, they just hold these mini USB connections and the connection to the main power module really secure with the zip tie. So all of these specific parts that may not be provided in the Tetrix kit or may not fit any robot, and it's kind of specific to yours, you can make a lot of those just by 3D printing. And it's slightly cheaper than using aluminum. So we used 3D printing to prototype those sprocket wheels. We actually printed a lot of iterations of those wheels using 3D printing. And we were able to attach them and still see how they work without investing our aluminum resources. So yeah, overall, so we went over how to download the software, how to get started, how to build a basic assembly, where you can learn how to do that, and kind of the uses of PTC and FTC, such as concept designs and analysis. So one thing we didn't go over is formula-driven design. How to do it, but basically it's just a really nice feature of PTC where you can build dimensions in relationship to each other. So if you sketch out a rectangle, you can have these two sides be 1/2 the length of these two sides at all times. So if you change this dimension from 6 to 4, these sides will change from 3 to 2. So it just it saves you a lot of time in that way. And you can also use Mathcad, which we talked about in the engineering notebook presentation, which is also provided by PTC for free to do all your calculations.